When you've learned to add and subtract roots, the next operation that needs to be learned is multiplication. A key thing to remember with multiplication is that anything that is outside the root gets multiplied by those things that are outside. Anything that is inside gets multiplied by what's inside. In other words, with this example, we see a 3 and a 2 outside. So 3 times 2 will give us a 6. We see a 5 and a 7 on the inside. So 7 times 5 will give us 35. Notice I did not multiply the 3 by the 7 or the 2 by the 5. It's 3 times 2 because they're out front, and 5 times 7 because they're inside. Now, other than that, the multiplication will go a lot like multiplications you've worked before. In other words, if you have the square root of 3 times 6 plus the square root of 3, you're going to basically use your distributive property like you have before. You're going to multiply first and get 6 square roots of 3. Again, remembering the 6 was outside of a root, so it stayed out. The 3 was in, so it stayed in. Next, you'd have the square root of 9. Since both 3's were inside, they will get multiplied together. After you do this multiplication, you'll do any simplification possible. 6 square roots of 3 can't be simplified, but the square root of 9 can, so I perform that operation. So basically you're multiplying something that is similar to one term times two terms, which of course we do with the distributive property. Let's try another one. Let's look at the square root of 5 times 2 square roots of 8 minus a 2. We're going to first multiply here. We'll have 2 square roots of 40. Again, the 5 was inside times the 8, which was inside, minus our next multiplication will be 2 square roots of 5. Again, looking for any kind of simplification possible. 40 will break down into a 4 times 10. We take the square root of the 4, and that will give us a 2, which will be multiplied by the 2 that was already out there. End result will be 40 square roots of 10, 4 square roots of 10 minus 2 square roots of 5. These aren't like terms, and they can't become like terms. Let's try another example. Let's take a 3x and multiply it by a 4x minus 3 square roots of x. First multiplication will be here. 4 times 3 is 12. X times x will give us an x squared. Next multiplication will give us minus a 9 x square root of x. There's nothing here that can be simplified. So we need to move on to a different multiplication. This looked like one term times two terms. So the next thing we will do is 2 terms times 2 terms. We'll take things like 6 plus the square root of 3 and multiply it by 4 minus the square root of 2. Now, even though technically these aren't binomials, we will use a multiplication process that will look a lot like the FOIL method. In other words, first times first will give us a 24. Your outer product will be minus 6 square roots of 2. Your inner product will be a plus 4 square root of 3. And your last times last will be a minus the square root of 6. And we look at this closely and realize there's nothing that can be simplified. We have no like terms. So basically that's all we can do with that particular problem. Let's look at another one. Let's take x minus the square root of z and multiply it by 2x minus 3 square root of z. Again, using a technique that closely resembles the FOIL method, we get that first times first is a 2x squared. Your outer product is a minus 3x square root of z. Your inner product will be a minus 2x square root of z. And your last times last will be a plus, because minus times minus gives you plus. 3 square roots of z squared. Now, unlike the last one, there's a little bit that can be done here. Now, the 2x squared has nothing there that it can work with, but these two middle terms happen to be like terms because they both have the x's, they both have the square root of z, so they'd be combined. And the last one has a square root that can be taken, so that's what it takes to finish up the problem. Now, with this particular type of multiplication, there's some interesting things that can actually end up happening. If I was to take the square root of 5 plus 7 and multiply it by the square root of 5 minus 7, as you can see, the two things that are being multiplied are almost identical, except for one has a plus while the other one has a minus. Let's see what happens as a result of this. The square root of 5 times the square root of 5 will be the square root of 25. That's your first times first. Your outer product will be minus 7 square roots of 5. Your inner product will be plus 7 square roots of 5. And your last times last will be a minus 49. Now, as you can see, we have one perfect square here, which we can take. The interesting part about this multiplication is when you follow this pattern, the inner and the outer portion of the product always cancel. And you actually end up with all square roots disappearing, and you're going to get a single rational type answer. This works with constants. It also works with variables and a mixture of the two. Had a square root of 3 plus square root of y, and if I were to multiply that by square root of 3 minus the square root of y, we'll see the similar thing happen. First times first is square root of 9. Your outer product is minus the square root of 3y. Your inner product is plus the square root of 3y. Your last times last is minus the square root of y squared. So we see that the square root of 9 is 3. Again, the two next to each other cancel. And the square root of y squared is y. So again, we end up with no radicals. This pattern is a very handy one to use in later sections